Excellent. Okay, Christine, I don't think I need to introduce you again. People know you now very well. You already started sharing your screen, inviting people to take part in this call. So, Christina, I give the command over to you.
Thank you so much. Okay, so I've started a poll for us just to check that everyone is with us and know how the software works and all of that. Oh, beans, interesting. What kind of beans? So we'll run this poll, and then by the time we're done with it, everyone should be ready to go. So what we're going to do in today's session is we're going to look at it's just a quick recap of what we did last time. We're going to carry on, and we'll finish off with descriptive statistics today. Then in Monday's session, not tomorrow, there's no session tomorrow for me, there we will do an introduction into distribution. So we'll add some simulation and all of that. And yeah, that is the plan. So today we are going to focus on just, again, descriptives. We'll look at a little bit of more complicated, if you want to call it that, descriptives as well. So the ggplot package. And then, yeah, we'll look at some loops as well. I enjoyed the loops in the Python bit, so I thought let's bring that in here as well. So there's still 42 seconds left in our poll for what the favorite food is. So far, beans and sushi are neck and neck. I also want to hear in the chat in the meantime what you guys think of are so far, if there's anything that you've gotten stuck on, anything you've tried that you want some feedback on. Feel free to add in the chat. I can see the chats as well. Still very quiet in there. And I see we've added pizza to the mix as well. So three foods neck and neck. 5 seconds left, and then we'll jump into the class. Okay, so pizza, sushi, and beans are the best foods in the world, apparently. I'm gonna vote for sushi, so we'll take it from there. So then let's get going with today's class. So what we've done so far is I've placed some installation instructions, quite a few different instructions on Moodle. So whichever one works best for you is what you do. We also looked at how you can get help for names for functions or data sets. So I've just put an example here. If you put a question mark and the name of whatever it is you're interested, you're gonna get some help on that. There's also a double question mark with the name of a function. If the one question mark doesn't work, sometimes 2 question marks will work. I haven't used that a lot myself, though. Most of the time, 1 question mark will be enough. Then the library function is used to load packages. So you need that before you can actually run anything in R or load your data. You need to just load the library first that contains that data set, unless it's in one of the packages that loads automatically, like datasets package. And then we looked at a few different functions. So we used the data, which you can use to find out what data sets are available. You also use it to load some of the data sets. The names function, which gives you all the names of the variables. The head function gives you the first 6 lines in a data set. The summary function gives you a summary of what's in your data set. Then you get your have your get working directory and set working directory functions. And then read.csv is to read in a CSV file. So read_CSV is what you would use in Python. Here it would be just read.csv. So just don't get confused with those two. But I saw with Spider as well as with RStudio, the computer basically predicts what you're trying to do, so it shouldn't be an issue. Then the table function gives you frequency distributions, and we looked at the bar plot function. So that is where we stopped. So any questions on this so far? You're also welcome to switch your microphone on. Don't need to have permission to do it. You can just switch on and ask any questions you want now as well. So far, I'm guessing then everyone is okay. No issues yet. Perfect. R is easy to use then. So then what we will do is we'll carry on over to R now. So we're going to look at a few of these different plots, and yeah, let's go there. So the first thing I want to do today is just not open this one. Let's go back to the session 1. So we're going to finish with the session 1 code. I've just called mine complete because I wanted to save it separately. So I still have my original template, and then there's a session 2 template that's available on Moodle as well. We will look at that after we finish this one. So the first thing I want to do today is just again set my working directory. So I'm just going to do it from my code because otherwise it's not going to find anything, any of the files I'm looking for, or save my files where I expected to save them. And then I also want to load the open intro package just in case I need it. So to load it, again, I just use the library open intro command. I just want to double check the size of my font. Is that large enough for everyone to read, or should I zoom in a little bit? Okay.
I think it's fine. Okay. Christina, it's yeah, it's not huge, but it's readable.
Okay.
Yeah,
okay, perfect. If anyone at any point wants me to zoom in, I'm happy to do that. Just let me know in the chats. Okay, so we did a few different things here. We're going to skip over all of this now. And the thing that we ended with last time was subsetting. So I mentioned subsetting and said maybe go have a look at it. But yeah, that's basically just if you want to create a new set of data using an existing set of data, but based on some criteria. So just as a reminder, let's just look at the first few lines of the fast food data set again. So if we do that, I use the head function, and you can see this is something that's going to come up a bit later. This is actually not saved as a data frame, it's saved as a tibble, and it's just showing me the first 6 lines of that tibble at the moment. So if I just type here head of not head of fast food, I just type fast food, that should show us a little bit more, and you can see it then shows us there's actually 515 rows of data, 17 variables. So a tibble is actually just a special type of data frame. It's a more modern way of looking at a data frame, where they've worked in data frames and kept it, and gotten rid of some of the redundant features of data frames that they felt weren't really necessary, maybe added some useful features. I'm not an expert on tibbles. I only learned about them the other day. But that's the explanation that I got. So in one of the exercises we're going to just convert it to an old-fashioned data frame just to make things a little bit simpler. What is really nice about the tibbles is when you print out a data frame which is saved as a tibble, it does show you for each of the variables what type of variable it is, which it doesn't do in the traditional data frames in R. So you can see most of these are saved as doubles, which is basically just a number which could have a decimal if it potentially does. Some of these are actually integer values. It seems to save everything as doubles. I'm not 100% sure why, but that's how R does it. Now, if we look at this, you can see that we have the different restaurants. They have different food types there. If we wanted to view this file properly, you could do it using the view function like I showed you on Tuesday. So just remember capital V, otherwise it's going to not work. I have made that mistake numerous times. So if you click view and the name of the function of the data set, then you can actually go view the entire data set here. So you can see there's a lot of McDonald's, there's Chick-fil-A, whatever that is. There's Sonic and so on. So you can see the item is just the name of the item on their menu. And then we have all of the nutritional information for each of these food types. And then salad, not 100% sure what that is, but it just seems to say other in that column. So that one for me is not the most interesting column to look at. So we're not going to do much with that. Now, if you go back to the subsetting, what I've done here is I've said, maybe I'm only interested in looking at the McDonald's and the Subway observations. We don't care about the food from the other restaurants. So I can go subset that using the subset function. And again, if you want more information about a function like the subset function, question mark, subset, press enter, and there you go. Now, this will show you all of the different arguments that you can use to subset, and it shows you a few different examples. So the examples I find really useful, and I use that quite often to figure out how to use a function. Sometimes the description itself isn't enough. So you can see they have the data set name, and then they have some conditions, and then you can also select only specific columns if that's what you want to do. If you don't use the select argument, then it will select everything in the data set that corresponds to that condition that you've listed. So yeah, I've just said I want everything in fast food where the variable restaurant is equal to McDonald's, or, and this is how we specify an or and R, it's just that line on my keyboard, it is just above the enter key. Or the restaurant is equal to Subway. And here we're using a double equal. So I haven't spoken much about assigning yet. You'll see in R when we assign, the preferred way of doing it is with an arrow, which you make by just doing the that bracket and a dash. You could potentially put an equal sign here as well. It does sometimes work, or most of the time it works, but there are packages that don't like you doing that. So best practice, as far as I'm aware, is to do the arrow thing for assigning. And you're basically just saying, take the subset function with these conditions, and whatever you get out of that, you assign into this new data set fast. So if I run this, you can see that I now have a data set, a data frame here called fast, which has 153 observations of 17 variables. So I took all of the variables there. So you can have one condition, you can have multiple conditions, and that brings us to our next exercise. I want everyone to create 2 data sets. So let's start with the first one. I want everyone to create a data set called fast TF. So _TF, that contains only the food items that contain trans fats. So maybe as a hint, I'll just put up a summary of fast food and we can have a look at it. And you can see there is a trans fat variable, and the values for trans fat varies from 0 up to 8. So I want you to think, how would you do that data set? And if you're nice and fast and you want to carry on with the next one, you are welcome to do that. So I'm going to give you a few minutes to do this, and whenever you are done, someone can volunteer their code for us in the chat, and then we can test it on, I'll copy and paste it. And if there's questions, feel free to ask in the chat or switch your mic on, whatever works. The first one should be quite simple. Second one also shouldn't take you too long to figure out. And as with Python, when you're checking for equality, you're using a double equal to check a condition. You don't use a single equal. So within a function's arguments, if you use an equal, a single equal, it means something very different from a double equal. Any ideas yet from anyone how we would do this? First part of the exercise. Yes, definitely, Isaac. So we are doing this exercise. I want you to create a new data set. So by subsetting the fast food data set called fast_TF, and it must only contain the food items that contain trans fats. So there's an example here just above that shows you how I created a subset of the fast food data set that contained all the food from McDonald's and from Subway, and I assigned that into the data frame called fast. So I want you to now just try it with a different variable, and I've put a summary of what's in the data set here at the bottom. And then there's a second task where you have to create another data frame consisting of all the food items that contain at McDonald's that contain trans fat. So there's more than one way you can approach that problem. This one first. And this is on the session 1 file is on Moodle. It's been there since Tuesday. So you can follow along in the same document on your side. You're welcome to just call me Christine. I'm not a prof yet. Anyone brave enough to venture or guess what the right code is? I'll do the first little bit. Let's see what you guys come up with. Anyone that wants to switch a microphone on, you're also welcome to switch on your microphone and tell me what you think I should be typing. I think I'm going to start picking people at random to ask for their code or suggestions. Let's see, I'm not going to start at the top. Let's start a little further down. Okay. Okay, so Donald is saying let's try that. So if we do that, I'm going to do that in the console. That's not going to help if I don't actually copy what I've just highlighted there. Let me just try that again. Copy. Oh, no, it seems like Zoom doesn't let me copy. Okay, so Donald suggested that we say fast food, $trans fat, and just that. And then what that does is it actually just goes into fast food and it pulls out the trans fat column and only the trans fat column. So we're actually only looking at all the observations for one variable. So that's not quite what we want to do. What we want to do is if we're looking at this fast food data set, we wanted to go look at each of these lines. And it must say, okay, trans fat, there's 0. So there's no trans fat. We're not interested in that. So if we go back to the instructions, it says we want all the food items that contain trans fat. So if we're looking at the first line, that should not be included. This line should be included because there's trans fats in there. That one should be included. That one should be included. And so on. This line here, line number 8, should not be included. So we want R to go through this data set. And for each of these observations, it needs to go and check if trans fats, if there are trans fats. If they are, then that gets that's part of the data that we're extracting and putting into our new data frame. So line 1 won't be there, line 8 won't be there, line 11 won't be included, but everything else so far then needs to be included. So we want to extract that. And what function do we want to use?
Subset.
Perfect. So subset, and then what?
Fast food and subset that data frame fast food.
Okay.
And then trans fat greater than 0.
Okay.
And then we select all other rows.
Okay.
All other columns, sorry.
Okay, cool. So if we just do it like this and I run that, let's open that trans fat 1. You can see here all of these values. I can actually do a quick sort according to trans fat, and you can see all of the values that we have here have trans fats in them. Thank you, Martin. That's perfect. So you could specify that you want only specific columns, but because we want all of them, we don't actually need to specify that. We can just say we want everything in fast food where trans fat is greater than 0, and then it will automatically give us all of those columns. So perfect. Now the next one, how would we do that one? Fast TF is what I said to call it, MCD, and I want to include all the food items from McDonald's that contain trans fats. So where trans fats is greater than 0 and the restaurant is McDonald's. So how would I go about doing that? Which data set should we use?
So
yeah,
once again, I think we use subset fast food, but then under that column where, can you go to under restaurant, then we choose McDonald's, right?
Okay.
So it would be fast food, restaurant equal to McDonald's, and then fast fat. It's what trans fat greater than 0.
Okay.
So it would be that is what the sign for a pipe. That vertical.
Yeah. Oh, this one.
Oh, it's supposed to be. It's supposed to be end.
Yeah.
Yeah. So perfect. That end.
So now the question is: do we do 1 and or 2 ands? Any ideas? What happens in most programming languages? Is it 1 or 2? Okay.
I think it's 1.
It's 1. Okay, let's try 1. I know some languages you use 2. So I actually tried this last night. So I'm going to do it. Let me copy and paste. So I'm going to do it more than once and just show what happens. So if we had 2 ands and we run this, you can see here, it makes it 0 observations. So then we know something's gone wrong because we definitely have those observations. So we know that that's not correct. So I want to actually try now what Eric is asking. He said, what happens if we say not equal to? So if we put exclamation and an equal, let's see if that works. That actually
That
does
works.
work as well. Yeah, perfect. So there's more than one way that you could have approached this. You could have also recognized that, yes, we actually have already a data set that contains everything with trans fats in it. So you could have said, well, let's actually just use the one that we just created, but that yeah, we could use that and just say we now want the ones from McDonald's. So I'm just going to delete that bit. And if we run that, you can see we again end up with 22 observations. So that's another way you could have done this. So there's not just one way that you can do it. You could use what you've done before, or you can use one of these other approaches that will get you to the right answer. So yeah, everyone happy with this? Cool. Okay, so subsetting is quite straightforward. This is not the only way to subset. You could also do it, let's say, for instance, you wanted just a specific column. So I'm just going to call it temp now, and you want columns, all the rows in the fast food bit. You could just do it with the square brackets. Put a comma so that you don't indicate which rows, which will mean automatically it will take all the rows. And then you can say columns 2 to 6, for instance. So if I do that and we view temp, you'll see that that has taken columns 2 up to 6 from that original data frame. So something just to be aware of as well. In Python, your indexing starts from 0. In R, it starts from 1. So if I, for instance, called up here fast food, and I put in square brackets, comma, just because I want an entire column, and I said column 0, it's going to give me a weird message. If I did it for column 1, then it actually gives me the information that I'm interested in the first column. So there is no column 0. Our indexing starts at 1, not at 0. So that's just something to be aware of. And that will come up a bit later again today. So that is another way that you could subset if you're doing specific values. There's other ways as well. So if you look at the textbook that I recommended in Tuesday's session, it's in that setup document. They do talk about subsetting in that textbook as well. So there's other ways that you could do it as well. The subset function is quite useful though. So then let's say we have our data set fast, which we created earlier, which contained the information for the McDonald's and Subway restaurants. And we want to go and do a box plot of the calories in all of the foods in those restaurants. Box plot function, very straightforward. But press Control Enter, that creates the box plot for me. So now there's other arguments that you might want to use on a box plot. So if you just put question mark box plot, it will show you all of the different arguments available. And you can see there's a horizontal argument. So if you don't want to do a vertical one, you want to do a horizontal one, you can do that. There's a color one, there's labels, so we'll do it, look at those just now. And yeah, you can just go through these yourselves, and a lot of these are the same in a lot of the functions in R. So the xlab, ylab arguments are available in a lot of the different plots that we do. There's also an na.rm argument that you can use sometimes to indicate when NA values should be removed. So if you have missing values, for instance, if you're calculating, I know in some of the functions, like I think the average function, well, it's called the mean function, not the average function, but means the same thing. If you have missing data or NAs in your data set, you might run into issues with that. You might get error messages and it won't do the calculation. So sometimes you would have to say, yes, please go remove those before you do the calculation. So if we go back to this box plot, let's say, for instance, we want to do a horizontal one, then you can just put horizontal, and it predicted it. So here it mentions that it's called horizontal, but without the rest of the word. It looks like they've changed it a little bit. So R predicted it. This is the correct one. Here we have a single equal. Horizontal should be equal to true. If I run that now, you can see that it has now shifted my box plot over. So box plots are really easy to do in R. Of course, we might want to put some labels. So if I want to put my X label, it's just the xlab function. And yeah, I can use single or double quotes. It really doesn't seem to make much of a difference in R. But I could type there, these are my calories. So if I run that, I've now added a label for my horizontal axis. I can also add a title, but the title is not called titles. So title is called main in most of the plots. This is my title. So if I run that, it adds it there. So all of these you can just add in here. If you press enter, let's say you don't want to put everything next to each other, it does some spacing here, but it's just for neatness sake. So in Python, we saw that it's really, really sensitive to your spacing. R is not sensitive to spacing. It is, however, case sensitive. So if I went and I typed horizontal with a capital H, I don't think it's going to work. Yeah, it doesn't pick it up. It doesn't know what horizontal with an H is. So it is very, very sensitive to case, not to spacing necessarily. Now, let's say, for instance, we wanted to do separate box plots for the McDonald's and the Subway. I can go do that. I can go create 2 data sets. And yeah, this is again another way in which you can do subsetting. So here I'm using the which function and I'm saying go to the data set first. And then all of the functions at which function goes and identifying everything which is equal to McDonald's. So everything in the restaurant column of that fast data set, which is equal to McDonald's. It goes and checks each row. You can see that because it's before the comma. So it goes and checks each row in the restaurant column and says, well, if it's equal to McDonald's, I'm going to include it. If it's not equal to McDonald's, I'm going to skip it. So if we do that, let's actually just get a quick summary or a quick, let's do a table of the fast data set, specifically the restaurant column, so we can see how much we have. So McDonald's, we have 57 observations. Subway, we have 96. So this is a less intuitive way of subsetting, but I wanted to show you a different way it could be done as well. So if I press here, Control Enter, it creates my McDonald's data set. And you can see here on the right-hand side in the environment, it does have 57 observations. So that is correct. Then the Subway one, I can do the same thing and it has 96 observations. So I now have 2 different data sets, which I can then use to go and set up 2 box plots. I can do one for McDonald's and I can do one for Subway. Now, that might not help us very much because if we look at these 2, you can see this one, we're not sure where it starts, but it ends at around 2,500 calories, where the Subway one ends at 1,200. So it's difficult to compare these 2 if they're on separate plots. So we might want to rather do side-by-side box plots. Now this one I've put in for 7 minutes. You're going to have to do some Googling here. So you might want to think about looking at the help file. I'll actually put that up on the screen. So for box plot, you're not going to be able to see everything properly, but you'll see some of the arguments. So I want you guys to try and figure out how would I do it that I have both of these plots on the same graph, so that scale isn't an issue anymore. And I want to do this based on that food data frame. I'm going to give you a few minutes for this one. This is slightly more tricky. So you can check whether there's an argument here that will help you with that, or if there is a different way you can use Google. Google is your friend. So I'll give you a few minutes to think, how would you do that? And you can make it vertical, you can make it horizontal, does not matter. Yeah, David, I can definitely do that. So I'll maybe post a separate one and just say this is the completed one, so that you have an empty one that you can go and try without looking at the solutions. I don't have any problem with that. As long as you don't do the classic student thing of looking at the answers and saying, oh, okay, I see. And if you have to go make up your own exercises and try something new. You're also welcome, if you are stuck on anything, you're welcome to send a message on the Slack channel, the statistics one. I am keeping an eye on that. And I will, at the end of the course, also give you my email address. Anyone who, like after the summer school, if you are stuck on something and you want to ask any questions, you're welcome to email me. So I'll give that at the end of the summer school. Anyone making any progress yet? Want to share anything you've tried that hasn't worked, then the rest of us can see. I'm just going to scroll up slightly if you wanted to see what I did there. Not that I'm saying that will help you, just for in case. Yes, Floyd.
Hi, sorry, I got in quite late because I was kind of stuck in the waiting room. I wanted to ask, is the box plot for all the restaurant, or is it?
Yeah, so basically what we want is we want this box plot we created and this one, but next to each other on the same plot. So not on separate plots. We want R to go split the data according to restaurant, so that we have 2 box plots of the calories based on the 2 different restaurants.
Okay, based on Subway and McDonald's.
Yes, yes. So using that fast data frame, the fast, oh, sorry, not the food, that should say fast, my bad. We called it fast, so we did that a little bit earlier on. You'll see it's in your script,
Okay.
fast, where we subsetted on those 2.
Okay, thank you.
So I'll give you guys a hint. It's not going to use these 2 data sets. It is going to use the fast. That's why I wrote fast there.
Okay.
So
thank you.
Eric says, Google says we need to separate the 2 box plots using commas. So do you have an example of the code, what it looks like when you do that? Is it something like, I'm just going to type in the console. Just going to try what I'm guessing Google is saying. And for that, I'm going to have to use the separated data sets. I've never actually tried this. Let's see if it works. If it does, I've learned something new. Oh, okay. So it did do something. That's one way apparently of doing it then. I'm actually quite surprised. But yeah, the way that I was looking for, Mpumelelo, sorry, I was a bit slow with getting the pronunciation, said we will do fast calories by fast restaurant. So it's not going to let me copy. So I'm going to quickly type what you've said there, box plot. And this is actually the way that I was looking for. I'm actually surprised that the other way worked. But it's a lot more work to do it that way. So we do fast calories and then a tilde, I believe that's what it's called, fast restaurant. So that's basically saying do calories or do a box plot of calories by restaurants. And if I do that, you can see it's done it. And it actually put the labels for us, which is nice, which was missing from a previous one. So if we look at this one, we actually can't tell which data set is which one. So I just put a 1 and a 2. So that's not ideal. So then I like what you did with doing some extra things here. So I'm going to add them one by one so that we see for each of your arguments what actually happens with this. So steel blue is the color you chose. So let's see what that looks like. So you have steel blue as your color that fills up then the box plots. Then your title using the main argument is calories per restaurant. I would maybe just change it calorie distribution per restaurant. So that's adding our title, and calorie has an E in it. Then you've also said XLab. I like you already because you are labeling things. Thank you so much. That is one of the worst things when people do graphs and they don't put labels. It drives me completely insane. So I'm going to add these labels and then we'll check them. So XLab, YLab is then restaurant. And then I see you put horizontal equals to true. So if we do that, there we go. So now we have restaurant, the names of the restaurant, we have a label there. If you were in my class, you would have got full marks for this question. So thank you very much for putting the labels and everything else. That is perfect. So you can see it's actually quite simple doing the box plot and doing the split without having to split the data yourself. There are ways of actually doing the colors differently for the 2 of those. And I'm going to leave that as homework. And then maybe in Monday's session, before we start, I want to hear from you guys. So figure out how to make the 2 plots have different colors. So let's make the one blue and the other one something else. So at the beginning of Monday's class, Someone has to tell us how to do this. That's your homework. So well done on that one. Thank you. Then anything before we move on to histograms? Any questions or anything else? You can give me a thumbs up as well if you're fine. Very quiet. I'm going to assume very quiet means you're happy, not that you've run away and hidden in a corner. I saw a thumbs up, so that's good. Okay, cool. So the next one that we're going to look at is the histogram and hollow histogram. So these are things that we've all used, maybe not hollow histograms. Hollow histograms were new to me as well when I saw that textbook, but I think it's really cool. So I thought I'll share it with you. So there's a dataset CDC available with the Open Intro textbook. It has a lot of different information in it. So it's a survey, a telephone survey that's done by the CDC in the US, and they're looking at risk factors. There's all of the information. I added that in for you so you know where the data came from. And we can read that data in from the web. So you can use the source function to read data in from a website. This is obviously already in R format. There's different ways of doing that as well. I'm not an expert in getting data off the web into R. This is one way that I do know of though. So if we run this code, you'll see that it has created a CDC data set for us, or it should create a CDC data set for us. Yeah, there it is. So there's 20,000 observations in this data set of 9 variables. So first thing we want to do, you can't start analyzing anything before you actually know what's in the data set. So I'm going to just say, let's look at the names and just see what we have. So there's general health. There's something to do with exercise. There's health plan, smoke 100, height, weight, desired, age, and gender. So if we just look at the head of this data set, again, first 6 lines, you can again get an idea. So it looks like this exercise, that would be, I'm going to guess, do they get any exercise? And that is an indicator variable. Health plan, no idea what that is. Smoking, I'm going to guess again, is an indicator variable. The information you should be able to figure out from the CDC's website that's given here, or from the Open Intro website. I know this is used in one of their labs. So if you want to practice some R, you'll see there's some lab assignments where they take you through different skills in R and the statistics that go with it. There's a few exercises you have to do yourself as well, and they do discuss this data set in one of those labs. Now, for histograms, there's more than one way we can do it. So we can use the old-fashioned histogram. So weight obviously is going to be a numerical variable. So remember, histograms deal with continuous data, not with discrete. For discrete, we would use a bar plot. So you can think back again to first year stats if you've done it. Otherwise, those tree diagrams that I showed you on Monday that show you what types of graphs are appropriate in which circumstances. So for continuous variables like weight, we can do a normal histogram. So I'm just going to use the hist function. And again, if you want to learn more about it, question mark, hist, press enter, and it will bring up some information about the histogram function. So you can see here, you have your data, the breaks, you can specify, and it does tell you here by default, I think it uses Sturgis rule. So it does try to do some pretty, well, you can do pretty values as well. There's a few different things. We'll just leave it on default for today. We're not going to worry about how we choose the breaks. There's a whole bunch of things. Main again, X limit, you can actually choose which limits to have. Same as with box plots, you could choose to not show all the outliers. You could have cut it off earlier. Labels are there as well. There's a whole bunch of arguments. So you can go through these yourselves. Now, if we do that, the histogram for the weights, by default, it gives us this horrible title, which we don't want. You can go and change it using that main function. It gives us a label, which looks horrible as well, which you can also go and change quite easily yourself. It does say frequency here, which is completely appropriate. We don't need to change that. So do breaks represent the number of bins? Yes, that is the case. So bins is just, I don't know why they call it bins, but bins and breaks are very similar. It's just how many breakpoints do you need, or how many categories do you need? So it's the same concept, basically, yes. So yeah, you can also then, let's say, for instance, you want to do a histogram of the weights, but you want to do it only for the males. You can do that, and you can do that by saying, do a histogram of the weights, but now we're accessing in there only the observations where gender is equal to male. So if you look at that data here, you can see gender was specified as an M or F, lowercase. Remember, it is case sensitive. So if I do it like this, I'm saying do a histogram of weights, but only for the males. So accessing only the males, and the next line is accessing only the females. So if I run that code, you'll see that this is what the males look like, the histogram of the males, weights, and then we can do the same thing for the females. And there's a little bit of a difference that we can notice here. But again, we don't want to sit here and scroll back and forth the whole time and try and figure out what the differences are, because the other thing is also, as I do that, you can see that the scale here on the y-axis is shifting a bit. So we would want to maybe do it all on the same graph, and that's where the hollow histograms are actually quite nice. So a hollow histogram is not a default function in R. So if you look here where we were looking at the help now, for the hist package, the hist function, you can see is in the graphics package. So that's something that's loaded by default. Now, if you look at the next one I've done, we're using the hist plot function. And that, if I go to the help, you'll see is actually a function that was written for the open intro package. So if you don't have the open intro package loaded, it's not going to work. So if it's not loaded yet, you just need to say library open intro, and that will load it for you. I think we did do that at the beginning. And then this histplot function has a little bit more flexibility to it. So if I use this histplot function, what I've done here is I've said I want first to add all the weights of the, or a histogram of all the female weights. I'm going to do that with a border, which is blue-violet. It must make it hollow for me. And then I've put a title and labels in here. So if I run this piece of code, this is what I end up with. So I have this purple outline of the histogram. Now, if I then go and do the same kind of thing for the males, you'll notice here now I don't have to specify the labels or the title because it's already there. What I've done instead is I've said go and add this. So add equal to true. So I could have typed out true. It also works with just a capital T. So for lazy people, that is quite useful. And if we run that, you can see that it just goes and plots that in green because I've specified green over the original one. And that's it. So now we can actually do that comparison much more easily directly. But still, this is not a perfect plot because there's no legend. So I have specified a legend myself. I'm using the legend function. And I'm saying put the legend in the top right of the graph. And then I specify females and males should be my legend items. So I'm just concatenating them by using the C function and in brackets putting then the two strings separated by a comma. And then I've put the colors in the same order that I put them here. So if I swap the males and females in my legend, I just need to remember to do it for the colors. And then I can specify what type of symbol to use in that, and whether there should be a boundary box. So if I run this, it adds a legend for me with stars. You can see I've used stars there, and it didn't give me a boundary box. And that is how you would do this manually. So you can do a default legend sometimes, but obviously if you're doing it step by step like this, where you're adding onto an old plot, then you're going to run into issues with the legend. So it's better to do it from scratch. So you do have some flexibility with legends as well. Everyone happy with this? Any questions so far? Has anyone used a hollow histogram before or seen one before? I'm quite curious to know. Cool. Awesome. Yeah, so it's nice with histograms. I know with bar graphs, it's easy because you just do the side by side or the multiple bar charts. And it's always an issue with histograms because everything touches. So I think this is quite a nice workaround to that problem. So yeah, so those are the basic graphics, just to give you guys an idea of basics. The plot functions are quite straightforward. I obviously haven't shown you all the different plots you can do, just a few of the basic ones. So I want to show you very quickly now ggplot, which is the more powerful one. So that's similar to pyplot, which was shown in one of the Python sessions. It's a little bit more advanced. So most of the time I actually use the old, well, the built-in ones, unless I'm doing something for someone in industry, then I'll go to the fancier plots. But if it's just for graphs we're doing with the students, we tend to use the simpler route. We also don't teach them ggplot. So this is just a little bit extra. So ggplot is also built on the basis that you're adding to a plot. So I'll show you a few different things that you can do in ggplot. I don't know if anyone's ever heard of a violin plot. Violin plots are also something that I think most people probably wouldn't have heard of in their undergrad, but it's really cool. So a violin plot is actually, once you see it, it's a combination of two very well-known plots. It's a combination of a density plot and a box plot. So you can do density distribution side by side as well, and you can do that very well with violin plots. So we're going to do something a little simpler than that. So in this case, I'm again using the CDC data, and there's this aesthetic function which tells it what to put where. So I'm just going to tell it X, just leave it open, and Y, I want to put the weights. We could swap them around as well, and that will just change it. Okay, Sinead, that's good. It's good to know someone is actually using it. I actually saw it for the first time. We had a professor from the University of California, Berkeley, that came and did a 3-day workshop with us a few years ago, and she showed us the violin plots, and yeah, I just loved it. It was such a cool idea. And it was after I saw her presentation that I actually that semester started teaching students R, because I thought, well, Excel isn't enough. We need to do R as well. So yeah, so with ggplot, what you do is you specify what data set to use, and then you can add onto that plot and you kind of build it up. So similar to what you do in Python as well. So you're telling it what to put on the x-axis, what to put on the y-axis, and then you tell it, I want a violin plot. And you can add extra arguments in there. There's actually a ton of really, really good videos on YouTube on how to use ggplot and get used to like the basic structure of ggplot. I would recommend that if you're interested in learning more. Then you add your box plot, and you can specify the width, for instance, in there. you have a function or an argument then that you can go into all your labels and your title. This is one of the few places where we actually use title and not main. So ggplot doesn't use main, it uses title. And I think there's a subtitle function, if I'm not mistaken, as well. And you can see each time we're just adding. So all of these things are just added onto your plot, and then it builds it. So the thing I do have to warn you is if you try and run this line by line, it's not going to work. You have to run the whole thing in one go. Otherwise, it doesn't seem to work. So then you can also do a theme, and this will help you specify, that should not be done. That will specify a few, some of your elements as well, what you can, where they're placed, what they look like, and so on. So I'm going to run this code, and it says it can't find the function, and that is because I actually haven't loaded my library yet. So if we load the library, then it does give me a warning to say it's built under a different version of R, but it still works fine. So if I now run my code, you can see there's my plot. So the problem with a box plot is you are limited in some of the information. You can see the problem with a density plot and with histograms is that you actually don't know what your median, your mean, all of those things are. So this plot kind of combines those two plots, and you get to see a lot more in your data. You can see the spread a lot better. You can see if there's anything funny happening. So these, I think it's quite nice. So we could change this around. We can, let's just swap these around. One thing I did notice when I was playing around with this as well is if you put your variables here in normal quotation marks, it does give you some errors as well. So I'll show that just now. I did run into some issues, but yeah, let's just see if we split this, or if we swap those around, you can see it just changes the orientation of my plot. Now, if we put weight in normal quotation marks, just want to show you what happens then. You can see that something just goes hopelessly wrong. So for some reason, when you specify which variable to use, it wants you to use these funny quotation marks. So on my keyboard, it is on the same key as the tilde, so above the tab key, on that same button as the tilde. And yeah, if we put that, we run the code, then it should work fine. So ggplot does take some getting used to, so that's why I'm not going too much into detail about it. I just wanted you to be aware of this is something that's a lot more flexible. And I'm curious to know if you guys have to guess this last line of code. If I change that 0.5 to something else, let's say I make it 0. Any idea what this means? What that H just would stand for? Going to just try while I'm waiting for you guys, see if there's a, want to try something else. Oh, that's not right. Any ideas what that stands for, that H just? Okay, Eric's saying maybe font size. Any other guesses? I'm going to maybe make it offset the title. Yeah, so that's your horizontal adjustment. So it's your horizontal justification. So if I make this 0 and I run this code again, you can see now it's justified on the left-hand side. If you make it 1, it's going to be justified on the right-hand side. And yeah, you can also do other things. So 0.75, then it's 3/4 of the way to the right. So that's just your justification that you can adjust there. So you would also notice that I just put a \n in the middle of that title. That \n just told it at this point, go to a new line. So that's another thing that you can do. Just to, if you see your title is overrunning, you can go and cut it off in different places and create a new line. So if you also want to do quotation marks, sometimes you have trouble with that. So backslash often will help you do special characters and things in your titles. So for this exercise, I have another one here for you guys. So I want you to see if you can adjust this code. I've actually put most of the code in here. I want you to create a side-by-side violent plot of respondents' weights based on the self-classification of their general health. And then that challenge we can leave for, or we can talk about it. So I'm going to give you a few minutes. I know it says they're 10 minutes, but I think let's try and make it a little bit less than that. So the only place where you're going to have to make changes in this code is in this first line. I'll tell you that now already. Oh, and of course, yeah, you can use this as a hint maybe. Okay, I see we have Floyd has given us some something to look at. So we'll put Gen Health there as Y, and X you have put weight. And then everything else is the same. Yes. So let's run this and see. And yes, that has done it. So the only thing I would change here is just because that's been cut off, I would maybe just go put a line break there and see. Yes, just because. But I mean, if we make the plot bigger, it might not actually be an issue. So basically in this, we've just said on the x-axis, we want our weights, y-axis, we want the general health, and R was clever enough to realize I need to actually now go split this data according to that. But there's a slight issue here. Is anyone seeing the slight issue that we have? If you look at the sketch, something isn't making sense here. Yeah, says weight in pounds, where it's actually the health self-classification. So if we maybe swap these around, I'm just going to do that quickly. And run that code again. Then we have weight in the right thing. We could, of course, have gone and changed the labels and just said the X label has to be the weight. Or we could have done it this way around. So that is pretty much it for this one. So you can see it's very straightforward. Once you actually understand what the arguments mean, you just add it. So you can go play around with it. You can go make this, let's say 0.3. If we do that, you can see that now our boxes are just wider. So very straightforward. Any questions so far? Okay. So the next bit that I have planned is also still on ggplot, or doesn't have to be if we don't want it to be. But I thought, let me just show you something that I promised on Tuesday, just how to export plots directly so that you don't have to go and save them manually. So I just want to quickly open my folder here. So this is my folder with all of the files that we've created so far. So this is my working directory. So in this working directory, we have a, you can see just the R files. I have that Python data from the other day, and that's it. So let's say, for instance, I wanted to create a plot, and I want to, I don't want to display it in R. I wanted to just directly export to my computer. I can do that. So there's a few different functions. There's a PNG function, there's a JPEG function, there's a PDF function, there's, I can't remember which other ones. I think there's a bitmap as well. And they all basically work the same way, that you start before you do your plot. And then you specify your file name. You can specify the width and height of a of the plot. So if you want something to fit in a specific space and document, you can go specify the plot beforehand. You can do different units, and then you do your plot and you use the dev of function. So if I run this, you'll see that it's running my code. Well, actually, let me run the whole thing together. And the only output I get is this RStudio GD2. It doesn't show the plot that's being created here. But if I go into my folder, you'll see that now I have a PNG plot here. And if we go to, I think I have a preview pane. It's always very slow doing that. But if I open this, you'll see the plot that I've just created. It exported it directly for me. So this is really useful, especially if you're doing a lot of plots. So my research at one point, I think my original master's dissertation had over 300 pages, and a lot of that was images, because I'm working in a field where there's a lot of images that we deal with. And I'm not going to go save each of them separately. So what you can do is you can set it up so that it creates your images, it creates automatic file names, and it saves it for you. So the last exercise that I have for us for today is something along those lines. So I thought, let's use the fast food data set. We've worked with it for a while now. We know what's in there. And we want to maybe go do some scatter plots. So we know in this data set, and I'm just going to open it again. So let's say view fast food. So we're going to combine a few skills now. We have the calories, and we have all of these different things, nutritional information in this data set. The last column is useless. We don't even know what it is. It's something to do with the salad. So in this, we have a lot of information which we can use to go do scatter plots. So let's say we want to do a scatter plot of calories against each of these separately. So I want a calories and cal-fat scatter plot, calories and total fat, calories and saturated fat, calories and trans fat. And for each of them, it needs to create a plot, which it then needs to export and save. So we're not going to view the plots here, although I would suggest, if you guys, as you're doing this, maybe first figure out how to do the plot and then figure out how to get it to automate everything. So I've given you a few hints here. I've said, let's create a new data set called FF, which is just that fast food data set. So we don't have to type fast food each time, but I'm making it a data frame. So I'm converting it from a table to a data frame by using the as.dataframe, as.data.frame function. So if I run that, you'll see there, it's still the same information, 515 observations of 17 variables. But if I go and check here with the is.data .frame function, and I put FF in there, it tells me, yes, this is a data frame. So I then also created a thing called FF names, which is just the names of the variables or the names of those columns. So if we view that, if I just print it, FF names, then you'll see it's just all of the column names. So that's maybe useful for doing the labels. So the first thing we would want to do is figure out how to do a scatter plot, because I haven't shown you yet. And then you can use a for loop. So I wanted you specifically to use the for loop here because you've done it in Python, and I want you to see the differences between Python and R. So I might help you a little bit, but I think first thing we want to do is just figure out, let's say we want to do the scatter plot of calories against whatever cal fat is. How would we do that scatter plot? So who can tell us how to do the scatter plot? And if we check and I start typing scatter plot, you can see there's no scatter plot function. It's actually simpler than that. If anyone knows what function we should be using, you're welcome to venture a guess. Yes, David, I think it was David that switched the mic on. Or was it someone else?
It looks like it's just scatter from what you typed in.
Yeah, no, definitely not based on what I typed in. So yes, plot XY. Yes, Floyd, you have it. So let's say we want to plot just those. So then we could do it, plot. So I'm going to give you guys a hint now. So we can do plot and XY. So let's make X just to make things simpler. We'll make X fast food, and you could say fast food and put calories. I hear someone's microphone on, but I can't hear them. Oh, that's not the right button. I'm not sure. There's someone talking, but I can't actually hear what you're saying. Tajadeen, is that? Sorry, we can't hear what you're saying, unfortunately. But yeah, so
Christine,
yes.
Perhaps you must try to type it down if you can't. We can't hear you.
Yeah.
If there's a problem, yes.
No, I agree. Definitely, we want to hear what you're saying, but we can't hear you. So I think typing is a good solution. So I've shown you now quickly. This is one way to do this. But if you're going to want to use a for loop and loop through the possibilities, then that's not going to help us very much. So we maybe want to use something else, and it's something I showed you earlier. So if I put plot FF and I want to reference the column that contains the calories, how would I do that?
Is it just comma and then the column number, which is 1, I think? Is it 2?
I think it's 3.
3.
So so we have restaurant, then we have the food item, and then we have the calories. So yes, so that would be 3, and then we do the same thing here. Thanks, Eric. And we do for column 4. So not enter, because then it goes to a new line, control enter, and then it runs it. And you can see that I now have that. But now I have dreadful labels here. So maybe we need to change the labels. So we can say here, xlab is equal to, and what do you guys think? How would I reference that? So do I have like a vector maybe with the names? Or a list with the names? I do. So I went and created something, ff names. And obviously on the x-axis, I would want to put whatever corresponds to 3. Now this is just a list. So if I put comma 3 here, you'll see if I run this, it says incorrect number of dimensions. So then I should realize I'm actually not dealing with a data frame. I'm just dealing with a list. So that comma is unnecessary. So if I run this now, you'll see that it has changed that label now to calories. And then I can do the same thing here for Y labels. And let's call it ff names and make it 4. And then when I run that, you can see this, it's still a horrible looking label, but I mean, we're just going to deal with it like that now. And then we can also do a title. And that is your homework, is to figure out how are we going to write this? How will we do this? So for homework, I'm going to leave this with you guys to figure out how can we combine a sentence with these two names. That if let's say I want to say, this is a scatter plot of calories and cal-fat. How would I do that so that it's based, well, combining everything, concatenating it into a single string? So that is part of your homework. And then how would I change this line of code so that it creates each of these plots for all of these variables, and it exports it to my computer into my working directory. So that I think is going to be the homework. And then for homework, it's figuring out the colors for the box plots. How do we do the two colors separately? And then also, because we haven't done that here either, so that bit I didn't show you guys. So that challenge is still standing. It's not here, it's actually the previous one. Then also, how would we finish this exercise? So I want you guys to do that when you have some time over the weekend and figure out, it's very straightforward. So you'll be able to figure it out in Google very quickly. And then when we start on Monday morning, then I want the answers to those questions that I've asked. And I think that's then enough for today, unless there are any questions. Everyone still with me? Any questions? Anything you're unsure about or that you want us to look at specifically?
Feel free to ask questions. You still have about 5 minutes left. Christine will probably, if you finish your exercises on Monday, you'll get some virtual lollipops.
Yes. If we were face to face, I might cupcake and give them away, but we're not face to face, so.
Yes, I understand. We used to do that in the past. So allow them questions and then answer them. Have some lollipops for them.
Yeah. I used to bake cake or cupcakes for my best students. So if you were either the most improved from one test to the next, or you got the highest mark in your group, then you got a cake in front of the class. So it's incredible how much effort they'll put in for cake. It works.
Probably have more energy than lollipops.
Definitely. Yeah. So definitely, Eric, I will go and upload this. So I'll call this session 2 almost complete. So I'll add that just now for you, and then you can just go and try and finish off what we've done. So I'll put it on Moodle. So the templates are on Moodle. I don't know if anyone had trouble finding them, but they are there. And then I'll just go add the completed session 1 file and the one that we're busy with at the moment. I'll add onto Moodle. So just save this. Oh, I saved it with the wrong name, but that's fine.
Hi, Christine.
Yes.
I saw, I think the last exercise we kind of did, exercise 4. There was a part where like you put a challenge to see if we can fill the props with different colors.
Yeah.
We're kind of failing to do that. I've tried Google.
well, okay, a hint would be that the word that you need to use is actually in the sentence.
Okay.
And you might want to look at the aesthetics part. So that's maybe a useful hint.
Okay, no problem. Thank you.
Okay, you're welcome.
Give it a shot.
Perfect. Any other questions?
If there's no questions, I think we conclude the session. And thank you very much, Christine, for a very interesting lecture. So, we will see you again on, I think, on Monday. Yep. And then we'll see you again, student, tomorrow.
Definitely.
Okay, bye all.
Thanks. Thank you. Bye, everyone. Have a good weekend.